So attic ventilation, what can be wrong in your attic? As you likely know, especially this time of the year, there can be a number of things that can actually go wrong up in your attic. Our presenters today is Harry Jansen, who we're trying to connect with. Of course, myself, Claude Lawrenson. And the idea was I was going to present some questions, and certainly we welcome your participation to use questions and offer questions. And certainly we will try and get around to making sure we can get some responses or answers to those questions. So as I mentioned, Harry will be delivering a number of points. I'm going to be basically, the intent was I would ask Harry the question and he would offer a response. And as I mentioned, certainly if you have questions, please feel free to post them on the chat. So when we think about the attic space, you can see here a number of different points. So many different variations can define an attic space, typically defined by the boundaries between the ceiling and the underside of the roof. It may or may not be designed properly for your particular region. It must be insulated and must be well ventilated. It may or may not contain other systems such as electrical, plumbing, heating, and so on. But when we take a look at it, we start thinking about poor attic ventilation is due to inadequate vent areas, insulation blocking the vents. These can lead to a number of observable problems.
Okay, now I'm on, I think.
Okay, thank you, Harry. So I'm just going through the introduction and
okay, thank you, John.
Okay, so basically I wanted to do a little intro of Harry. Harry, by the way, is a business partner of mine. I've known Harry for, geez, almost forever, right, Harry?
Yeah, seems like it, doesn't it?
We go back to the early days of the Ontario Association of Home Inspectors here in the province of Ontario. Harry is a longtime home inspector like myself. Certainly he's been involved in the education field, teaching home inspectors on how to get into the profession and certainly teaching them about building systems in a home. He's been involved with upwards some years doing well over 400 home inspections a year.
Yeah.
You want to tell us a little bit more about yourself, Harry?
Well, I'm the past president of the Ontario Association of Home Inspectors and the past president of the Canadian Association of Home Inspectors. I served on the board of directors of the American Society of Home Inspectors for 8 years, and I worked on many different committees to do with home inspections.
Thanks, Harry. Again, I was just mentioning, I'm going to pose a number of questions. We're going to go through a series of slides, and certainly we're looking forward to your comments and your thoughts about some of these conditions and things. As we know, one of the big issues is certainly what goes on in your attic space of just about any home. In fact, not just any home, just about any building, if we think about it. So again, I'm going to read through a few of these and we'll get you going on some of these questions in a moment. Okay, Harry?
Yep, that's fine.
So we can see that attics and ventilation is an important part of comfort and energy efficiency. It moderates the temperature of the roof. It can be a place for storage. Some people like to use that for storage space. And if there's a pitch high enough, some even convert that into extra living space if the pitch is high enough, as we can see here. But it also can be a place for a number of hidden problems. So here's 3 images I wanted to kind of kick off to portray some of the issues that we might find in a typical attic space.
Yeah, one of the biggest problems if it's not ventilated properly is condensation. And with condensation, mold starts to grow. And there have been cases where the mold is so bad that it's rotted the structural members and the plywood. And of course, all that mold in the attic isn't healthy.
So again, just as a starter question, what are the requirements for attics and ventilation when we think about the attic space itself?
Well, as your diagram illustrates, air has to be able to circulate in the attic. Well, let's start at the beginning. Because the house is heated, and if it's poorly insulated or there's gaps in the insulation, the heat from the house will enter the cold surface and condense or freeze. And when the sun comes out, it melts. So we have that freeze thaw cycle constantly, and that's where the problem lies. The ventilation, air has to flow in from the soffit and flow up through the attic space and come out the roof vents near the peak. That's how air moves. And a lot of people, when they're insulating their attic, think, well, I'll fill those gaps up so cold air can't come in. Well, we want that cold air to come in and take with it any warm, moist air and vent it to the exterior.
Thank you.
And there's different kinds of ventilation techniques. Most of them are in the ridge, which is near the peak of the roof, but you can also have gable vents, as the diagram shows, or you can have a ridge vent, which is at the very peak of the roof. All of them work, and work well if they're placed properly.
So again, we have a couple of mock-up here in one of our, we'll call it inspection training centers. So we can see here what some, I guess we'll call them live or practical real examples of some different mock-up samples of ventilation, a gable vent, a ridge vent over to the right-hand side, and also the rooftop ventilator. The other thing, of course, we can see when we look at the left is we see that white styrofoam baffle, which helps the air circulation, obviously, right, Harry?
Yes, no, and whenever people are upgrading their attic insulation, they need to install some kind of baffle. It can be plywood, but the cheaper models are the plastic or styrofoam baffles. Air has to circulate.
Yeah, that's always the important part. Like you say, people tend to want to save energy by stuffing insulation into the we'll call it the overhang, and that typically is where you're going to end up blocking that air airflow.
Yeah, it's that airflow is so important.
My next question: are all attics accessible?
No, no, many attics are not accessible. Sometimes homeowners, when they renovate, want to get rid of that ugly box, they will call it, so they block it off. There should always be access to the attic because the homeowner or an electrician may want to install lights, extra lights. You may want to upgrade the attic insulation at some point in time. And so there should always be access to the attic.
So again, this slide depicts certainly a reasonable size. Certainly, we know as home inspectors, oftentimes if there's no access or limited access, we can probably only take a good peek at things maybe from a small open area as far as accessibility is concerned, right?
Yeah, yeah. And another mistake some people make is they don't put insulation on the lid of the attic. So of course, heat escapes around the lid. The lid should fit snugly and should be weather stripped and have insulation on top of it.
So again, this next picture we can see we have a very cold attic. We can see a lot of frost on the back of the nails and certainly on the rafters, the wood framing, and so on. So what are some of the common winter conditions we should be aware of, certainly now that we're in this time of the year?
Well, yeah, this is extremely cold weather for allowing conditions like this to happen. heat is escaping and it hits the cold surface and it turns to frost. And again, it's when it's poorly ventilated, and that's the biggest cause. It has to be well insulated and well ventilated in order for it to work properly. And so it's not a difficult thing to remedy. Increase the insulation and increase the ventilation.
Yeah, I think as we can see here in this depiction, we can see where, let's say, as things warm up and as heat escapes through the ceiling of a house, certainly we can see this water and condensation eventually will say what, damage the insulation, and certainly at some point even damage the ceilings in a particular house or building, right?
If it's wet enough, I have seen where the drywall has fallen down in a room because of the constant dampness in the attic, which dripped down on the wet insulation and made it so heavy that the drywall fell down.
Yeah, good point.
And another thing to look for when you're looking in an attic space is around light fixtures and any penetration, like the plumbing stack. Quite often the insulation is pushed away from there, so there'll be a lot of air leakage around light fixtures and plumbing stacks, or any other penetration up through your attic.
So going to our next slide here, I'm posing the question of what causes ice dams, and we can see two depictions here. One kind of looking at it with the regular camera and taking a photograph, and the second using that thermal imaging camera, the infrared camera, and we can see different temperatures. If we look to the right of that thermal imaging slide, that range between about 71 degrees Fahrenheit and upwards to 79 degrees Fahrenheit. But it also indicates to us, because we don't have X-ray vision like a thermal imaging camera helps us have, that when we look at something in a ceiling with our own eyes, we don't always see what's going on. We can see in this depiction here with the thermal imaging camera, something's taking place along that outside, well, we're inside, in this case, of the house, but looking along that outside edge where the wall and roof typically would meet in that corner. And usually those are vulnerable spots. And we often think about the issue of ice damming, right?
Yeah, and it's in some neighborhoods, in some areas, it's a real issue. People have resorted to putting heating cables on the roof. Again, an attic that's properly ventilated and insulated with very little air leakage should have relatively little or no ice damming.
Yeah, so I think that's an important part that certainly we get back to the issue of that ventilation, and certainly the importance between the association of the insulation in the attic and the clear ventilation space, and certainly the movement of moisture out of the space. Because basically when we take a look at this illustration, we can see with ice damming, it basically, the snow is melting, running down and refreezing, because when it gets to that outside overhang, it refreezes because there's not a lot of heat loss taking place there. Whereas we'll often see, even with frost on an attic, or not on an attic, but frost on a roof of a house, we can often see that sort of melting pattern. And we can often tell as home inspectors how well a home is insulated or not based on that frost melt pattern, right?
That's correct. We've seen some homes with 6-foot icicles hanging from the eaves trough.
Well, what about, you've been talking about the issue about air leakage or about tight insulation conditions. Again, we can see in this photograph up in an attic, a high-pitched attic, we can see a lot of that blow-in fiberglass insulation seems to be kind of encroaching upon that overhang of the eave. So again, we start to see this darkening of the sheathing on the back, which is likely visible signs to us as inspectors of saying, geez, there's been a lot of moisture happening up in this attic space. Look at the upper parts of the roof framing rafters, so to speak. You can see the darkening of the wood. Again, signs of water penetration and potential damage, right?
Yeah, yeah. It's so important that the ventilation and insulation be correct. So important to prevent damage, to prevent mold from growing. Plus, if the insulation's wet, it loses its R value.
Certainly. Again, as we can see in the illustrations here, over to the left-hand side, a lot of these air leakage points, Harry kind of touched on earlier, around exhaust fans, ductwork, even the attic access hatch, lights, plumbing vents coming up through, for example, in the lower one, the plumbing stack. So again, these are potential areas where if they're not sealed, air is going to move and escape up into the attic space. And this air is either going to be heated or in some cases heated and moist and causing conditions up in the attic that we don't always pay attention to until there's probably a major problem happening.
Yeah, that's for sure. Now, if you have an infrared camera, on a cold day like today, if you were to take some pictures in the attic, you would see where the air leakage is. It would show up really well
Exactly.
around light fixtures or plumbing vents or attic hatches, anywhere where there's a wall framing where the insulation may not lay properly, you'll see the heat escaping from an attic. Now, one thing about an infrared camera is you have to have a good temperature difference between one area and the other. Otherwise, it won't show up on the camera.
Exactly, yes. So the next question here, is it better to have a vented or an unvented roof? We can see here it says an unvented attic system relies on air seal with no vents to make the attic a conditioned space. By using, for example, air impermeable insulation like a spray foam on the roof deck, it will actually stop the air movement. So again, we can have a vented or an unvented attic, and most of the houses we know typically have the vented type attics.
Yeah, if you make it a conditioned space, it now is almost like a living space if you make it conditioned. An attic really isn't meant to be conditioned. It's meant to get rid of any moist air that gets into the attic space. And earlier it was mentioned that you can turn an attic into living space. While you can sometimes, but usually attics are framed just to hold the weight of the ceiling, not to hold the weight of occupants or furniture or things of that nature.
Yeah, so I mean, typically, as we know, you and I and other inspectors likely know, if we have 2x6 ceiling joists, well, your typical common floor joists are probably going to be something in the range of, let's say, a 2x10. So again, is it going to be designed to take the loading of, let's say, a livable space? So that sometimes becomes a whole other issue, right?
Yeah, that becomes a whole different. It would have to be redesigned in order to become living space.
So again, this illustration here is again a credit from Formline Architecture, and this is one of the diagrams of this unvented type attic condition. As we can see here, and what we've been talking about, or Harry's been talking about so far, is when we talk about the vented attic space, we're talking about ventilation of the attic space versus sealing up basically the rafters or the roof system into a construction system that really has very limited, in fact, really no ventilation going on within the roof system. But again, it depends on the type of system. And again, it has to be designed and thought out. And certainly there are examples of this happening even today. So there's a little bit of debate going on whether when we think about designing houses or building houses, should they be simply the vented type that we've seen for decades, if not for a long time, probably well over 100 years, or do we start thinking about things a little differently, especially when we get into the northern extremes, and how do we prevent ice damming? And of course, this is one of the details the architect has proposed here in this particular detail. So this is part of the credit is noted there. So this is part of a form line architecture in the housing report.
And that will work. That system will work, but it has to be sealed 100% or going to be more problems than with a normal attic.
Exactly. Boy, we have some more attic pictures to think about. Does lack of proper attic ventilation have an impact on the roof?
Certainly does.
So again, here we take a look. In many cases, the lack of good attic ventilation can void the warranty even of shingles.
Yes, and that's a really valid point. If it's too hot in the attic, the shingles tend to deteriorate from inside the attic as well as from the sunshine outside the attic. The heat is what the enemy of the shingles is.
Yeah, so again, we can see here in this depiction of the two images, we have the photograph using our naked, visual eyes and taking a look at the attic space versus a thermal imaging view of it looking over to the right-hand side. We can see by the different color gradations here, the differences in temperature that is being picked up with the thermal imaging camera. So in this case, in Celsius, from just below 19 and upwards of 23.3. So we can see there's quite a bit of difference in temperature between the different materials and surfaces.
Yeah, and the warranty and the shingle manufacturers are very particular on detail, and the warranty will be void if it's not done 100% according to their instructions.
Okay, so is that damage to the ceiling possibly from an attic or a roof, or maybe from both? So when we take a look at this next depiction here, we can see a damaged ceiling. And as we found out, water and moisture certainly can accumulate in an attic space, hence the need for good ventilation. So let's take a look at this. So what about ceiling damage?
Yeah, again, it depends what causes the moisture. Now, sometimes snow gets into the roof vents and it'll melt, of course, on a nice warm day. And it can cause the damage. So to determine, you'd have to look in an attic to see what the issue is.
Yeah, exactly. Another question that often comes up is more insulation better?
If it's installed properly, yes.
So when you think about this, it says, consider the law of diminishing returns. What are they talking about? Do you remember that, Harry? A law of diminishing returns?
Yes. Well, if you can put 4 feet of insulation in, but you won't get any more value from 4 feet than you would if you put in, say, 18 inches or 20 inches, whatever the code recommends. So you can put too much in because it'll have no payback.
So again, some of the risks, as we can see here in this slide, you want to comment about those, Harry?
Sure. Too much insulation, it can be uneven, which isn't going to help very much with our values. And again, if it's not installed properly and then not ventilated properly, you're still going to have issues.
Exactly.
So just by adding more doesn't necessarily make it better. It has to be done properly.
So again, here's another one of my images depicting an attic inspection. As we can see here, what is a cold spot? So when I start looking at this, I start looking at, first of all, these are, engineered roof trusses. So for the roof framing. And I start to look at the amount of insulation in comparison to, let's say, that 2x4 bottom chord of this particular roof truss. Does this kind of give us a story that we can talk about here, Harry, when we look at the amount of insulation?
Oh, yes, it's very uneven and it looks compacted as well. So it looks like either animals or something has been up there, or people maybe have stored material up in the attic. Insulation compacted loses its value. It needs to be nice and fluffy.
So these cold spots can exist, certainly, even maybe by Mother Nature itself, by just simply, we'll say the wind gets up through the vent and starts maybe redistributing some of that insulation, particularly close to the eave edge.
Yes, it moves it around. It can happen. Yeah. And it does happen on occasion. Now, sometimes you will go into a home, and I've seen this happen. You will see a spot of mold on the ceiling in a room. Might be a foot square, or it might be round, or it could be any shape at all. Quite often you'll find that spot has no insulation, or in the attic it's missing right at that spot. And the warm air of the living space is hitting the cold air of the drywall where there's no insulation. So you're getting some mold-like or staining on the drywall.
So I'm looking at this image here, and this is what some people refer to as the hot roof. So what we appear here, if we take a look at it, it appears that they've insulated the rafters or the roof joists rather than, let's say, the ceiling area. So
Yeah.
Any thoughts about hot roofs?
Yeah, it's installed wrong. And your first picture, insulate the floor and wall, is the proper way to do it. And not the picture on the right.
Yeah, so I mean, we can see the depiction of, let's say, the better way of doing it, so better building practice versus the one on the right saying, well, we're trying to stop it, but are we causing other issues to actually happen, right?
Yeah, yes, we probably are.
Well, should I block my gable end vents? Snow seems to keep getting in and causing leaks inside the house on the ceilings.
I wouldn't block them. I would possibly change the kind of vents that are there. They may be an old style and they're not working anymore. I wouldn't block any vents off.
And
I might change them.
You have any thoughts about this turbine vent?
Yes, I'm against turbine vents. I like the vents to work naturally. The turbine vents tend to seize up after a while, and they squeak for the longest time, and then they stop functioning.
Yeah, I think you pretty much hit most of those points there. certainly they can be good under some circumstances, but in many instances, not likely the best way of venting that roof space, right?
No, no, I don't like them because I've seen hundreds of them that don't turn even in the strongest of winds because they're seized up solid. So it doesn't do much good when it's not working.
Can I chime in here? In regards to turbine vents too, they only work if there's about 2 to 3 kilometers of wind movement. Other than that, they become a static vent. And the problem is people won't do the 1 in 300 for ventilation. They figure the turbine vent is just enough. And then they got a problem when there is no movement of wind. You have static, the air is trapped in the attic.
That's a good point. Very good point.
Certainly, and we can see also, under such certain circumstances, it can also depressurize the attic on very windy days. So you can have both extremes.
Yeah.
Something I wanted to add too is on gable end venting. In older homes, it was a common practice to gable end vent. We now tend to go with the ridge style venting. What happens sometimes too, what I've seen is gable end vents that are shortcut. So in other words, somebody will decide, well, they want to put more ventilation in and they'll put a rooftop vent right next to the gable end vent and it'll shortcut.
Yeah.
Shortcutting is very bad. The whole system behind the attic, as we're learning right now, it's a very dynamic and it has to be thought out really well.
So basically, I would take it that we want to draw in air through the lower soffits, and we want to get reasonably high up on the roof to basically take that warmer air in the summer months and basically get it out through the roof or the ridge vent, right?
20% of all ventilation is intake and it comes from the soffit ends, right? That's the number we like to use, 20%. And then of course, the rooftop, we say 1 in 300, but as Harry points out, it's better on the ridge top to have more than less.
Yes.
Yeah. Yeah. I don't think you can really, well, I'm not exaggerating, but I don't think you can have too many.
Yeah. And I often tell my clients too that that a roof system is an umbrella. It's not meant to be warm. It's only meant to shed the elements off. And that's how it has to be designed, as an umbrella.
That's a very good point.
That's correct. Yeah. Yeah, it's not meant for living space or storage, really. I don't like to see people store things because they compress the insulation. And if something's heavy, it can fall through. It can cause a lot of problems. The attic wasn't designed for storage or living space.
Well, again, when I look at this picture of this current photograph, again, I start to see roof trusses with 2x4, we'll call them bottom. And then we start to look at the amount of insulation, which means to me, there's only about probably an R12 insulation in this ceiling space.
And that's another very important point. The bottom cord should be covered completely with insulation to prevent thermal bridging.
Exactly.
Yeah, exactly. You shouldn't see the bottom cords when you're looking in the attic.
And that'll send a message up pretty clear the first shot that most trusses, wider homes, 30-foot and greater spans will have a 2x6 bottom cord, which is quite common. But if you are up in the attic and you see any one of those cords exposed, that's the first thing. There's an insufficient amount of insulation to reduce the stack effect.
Yeah, a very quick observation point that's easy. Even just peeking through the attic access, you can see that, right?
Right.
Yeah.
So what about this thing called truss uplift? What's happening, Harry? Do you know what this truss uplift stuff's all about?
Yes. Again, it has to do with the weather. And because the bottom cord is not insulated or kept warm, the same as all the rest, the wood tends to want to lift up and it'll pull the drywall away from the ceiling, and in some cases you get a nasty looking gap. There is one way to fix that, and that is to attach a piece of molding just to the truss, not to the wall. So when the truss lifts up or down, the mold will slide along the wall and you won't see an ugly gap. Again, insulation. It all has to be insulated properly.
Thank you. That's a good point. What about chimneys and vents? We've seen that there's been the potential for a lot of we'll call it heat and moisture movement up into the attic, especially during our winter months when we're heating our homes. We see here a good example of this water heater, and we see around this this flue, this stack, we can see there's a reasonably open joint. It's not well sealed. And of course, if we take a look just beyond it, we can see an open, we'll call it just sort of hole going up into the attic. So, you know, chimneys and vents and these ceiling issues certainly become big issues and big concerns. So,
Yeah,
again, some thoughts about chimneys and vents?
yeah, it's so important because typically insulation is poorly installed around chimneys and roof fans and lights. And especially if it's a retrofit, the contractor may be in a hurry and forget to neatly push the insulation around the light fixtures or whatever they're installing, or they may have installed the wrong light fixtures. Not all fixtures allow insulation to cover them. So
Yeah,
it depends on who did the workmanship.
Yeah, and I think that gets into the issue of the review the clearances. Certainly, as you mentioned, some are not designed to have direct contact with the insulation. So there's
That's correct.
a need to have clearances, certainly around particular objects such as the metal chimney flue there. Or in some cases, let's say, ceiling type pot lights?
Yes. Pot lights can be a real issue if they're not designed for insulation.
By the way, for those that are paying attention, think about a video. So on this slide later, there's a nice YouTube video about keeping attic vents from freezing in the winter, because I know I've often heard of this being a big issue. Rudy, any thoughts on that?
On the
The
keeping the attic from freezing in the winter,
yeah,
as Harry says, you got to have that attic so that there is air movement. One of the points that isn't stressed enough is that the poly seals on ceilings, where we talk about sealing it from air movement, that in my opinion is more important than insulation to prevent the transfer of moisture into the attic space. I mean, the insulation is important, but again, like a class A chimney, you cannot put any insulation next to it. B and C you could, right? But a common problem I find is the storm collars on many of these B vents are not sealed. And when you're in the attic, you can see a whole moisture around the insulation of those type of vents. So we want to stop all of that, right? So
Yeah, no, and Rudy, I agree. Air leakage is the number one issue, but also adequate insulation in today's climate is also an issue. But stopping air leakage is the main issue.
So when an inspector goes up into the attic, and even if you don't get up too far, you know, poke your head in and either skirt the insulation if it's loose fill or a bat, and just check to see underneath the plywood to see. And usually in older homes, they would have been paper, and you won't see the plastic or the poly. So there's things we can do without having to remove the insulation. So if you see that there is none as an inspector, you might want to make a recommendation on the inside that you use a vapor resistant paint on the ceiling. to help reduce movement of vapor into the attic.
No, that's an excellent idea, and that's what we've recommended to people in older homes that don't have a vapor barrier of any sort.
So
When we're looking at this next slide, we can see, are there issues with wiring in attics?
well, generally wiring can be left exposed like that. It really, there's in the electrical code, it states in any wiring that you have accessibility to has to have either protection or be covered below 4 feet. That doesn't apply to the attic.
Yeah, so we can see here, there's certainly in some areas it's not a good thing. In other areas, there are exceptions certainly to the rule, we'll say. So that's good to hear. It just depends on local jurisdiction or authority having jurisdiction in this case of whether it's a good thing, a bad thing, safe or unsafe.
Harry makes a point about pot lights in regards to, now that's an interesting subject because we have seen the evolution of pot lights where now we have these little pucks where you can just cut them in and put them in. They're not an issue. But for any inspector, and I do this also, when I do my first cursor look at a ceiling of an attic, I look to see if they're 4-inch or 5-inch or 6-inch pot lights. Usually 5 or 6-inch pot lights will send me a message that I need to look closer in the attic to make sure that there's either fire guarding around it and that it is insulated. Because a lot of times in older houses, the handyman just popped that pot light through and didn't do anything for it, right? That's an issue.
Oh, that's a good point, Rudy. A lot of the pot lights weren't designed for to be installed in insulation. They were meant for a basement or whatever, where there's insulation's not a concern. And another thing about wiring in the attic, when you're looking around in the attic, look for splice joints in wiring. So common when a homeowner, especially a homeowner, or do-it-yourselfer renovates or adds a fan or a light fixture, they tend to just splice the wires. Why bother with junction boxes and Moret connectors? Just a bit of electrical tape will do. You find a lot of electrical issues in attic spaces. I know it's a little off topic, but it's something to look for.
I think in a way we've already covered this next slide. Can I save energy by blocking my soffits? Certainly some people have the mindset that maybe it does, but in reality, I think you've already addressed that issue, that it's really blocking good, proper ventilation, right?
Yeah. No, you can't increase by blocking. It has to be vented.
So does it really save energy? Not really.
No,
It's causing other problems. So that it kind of negates the purpose or the extra energy to try and do that, right?
Yeah,
that's
you're
right.
destroying,
Yeah.
you're destroying the lid. The lid of your house is being destroyed. Yeah.
That's right.
Yeah.
How about vapor barriers? Do we really need a vapor barrier?
Not on top.
You don't like this picture? Well, they tried at least, but hey, they put it on the wrong spot, right? Wrong.
Yeah.
So what happened is you can see that this is a collar-tied roof and it's hand rafted, so it's an older roof. It looks like fir and it'd be about somewhere around the 60s that this house was built. And in
Yeah,
the
it
60s,
looks like it. Yeah.
yeah, they would have used paper insulation. Again, the gable end venting. It just sends me a message, and it looks kind of like a Mansa roof. But anyways, this particular situation is, it came to someone's attention that they're losing heat in the attic, and they figured the poly was the answer.
Yeah.
But the problem is by doing it on the surface, trapping all the moisture and everything between the drywall and the vapor barrier.
And that cellulose type of insulation is very susceptible to moisture. And that's another point.
Yeah.
When you're sticking your head in an attic and you see this gray cellulose, make sure you take a measuring tape with you and you measure it. So what happens back many, many years ago, installers would put in the 12 or 15 inches of required cellulose with no consideration of the 20% of compaction over the years, right? So what happens is you became, and as Harry said earlier, wet insulation doesn't work. Compacted insulation doesn't work, right? So that's a big, big, big thing when, and I find that on a lot of my First Nations homes that we have gray cellulose because they were done in the 80s, and that all needs to be retopped at about $2.50 a square foot installation.
Yeah. Now, cellulose insulation really is just shredded newsprint, which has been treated with a fire retardant and for mice and stuff like that.
And the message I want to send out about cellular, gray cellular, it is very effective and very efficient as an insulative blanket. It really is until it becomes compacted and moist.
Yeah, then it's useless. Yeah,
Okay.
then it's useless material. Now, some firefighters don't like it because it, I've heard that after it becomes old, it loses its fire rating capabilities. So when the firefighters pull the ceiling down, all that paper catches fire instantly.
I think the best stuff nowadays is that rock wool they use. The you can even get it loose, but the rock wool seems to be the best type of insulation. Another point, we were talking earlier about putting, let's say there comes a diminishing return on insulation in an attic. We've now moved here in the interior from R40. We want to see R60 for our insulation, but we've just realized to ourselves that's the thermal equilibrium. So at a certain point, when the energy leaves the home, like you say, you can keep adding and adding insulation, but a certain amount of insulation will create an equilibrium based at your means day of the year, which you'll find in your climatic charts, right? So if we have a -12 means day here in Kamloops, then we want to be able to sufficiently balance so that under the third rule of thermodynamics, we no longer lose energy. The energy is constant and equal, right? So that's what
right, yeah.
The diminishing return on insulation. There's no point. I mean, it's like sitting in your living room and putting 5 blankets on you when you know 2 blankets will do it.
That's right. Yeah, a good point.
Okay, some credits here. So credits and resources. A lot of the illustrations are from the Illustrated Home, a Carson Dunlop publication. Some of them are from Canadian Wood Frame House Construction, CMHC. I've offered in this presentation, we can see an unlimited almost supply of resources. There's quite a number there. So again, something you can follow up on. Building Science has some good documents about understanding attic ventilation. There's one about the conditioned versus the unconditioned attic space. And another good one, attic ventilation in northern Canadian climates, which is again a research publication. And again, another study done on ventilation in extremely cold climates, because as we know, not a one size fits all when it comes to attics and certainly attic ventilation and some of the concerns that we see in attic spaces. So I hope, Harry, and again, even with Rudy's assistance there, we've learned a little bit more about attics and what's really going on up in the attic space. So, think about taking a good look if you have a chance and see what's really happening. So again, thank you, Harry. Thank you, Rudy.
Thank you.
We're open for maybe a few more quick questions, answers, or comments.
Yes, we'd love to have some questions.
Well, it's John. I learned a lot. It's incredible because many of the examples, so my house is 1928, and I had to go in and redo my insulation. And I'm trying to find a picture, probably I'm trying to find, but I had to actually re-insulate one of my my bedroom walls with pink styrofoam, and I taped it with duct tape, but the foil tape, so it wouldn't fall off. And then I took a spray can of foam and went right around the edges. So that resulted in my upstairs, which is incredibly warm, and it also prevented. I had huge ice damming to the point I had to get a guy up probably even this time of year. I have no more ice damming, but interestingly, my ice dam has shifted to over my door, which I cannot get access to, which I might, if I'm going to repaint, I may knock out a hole and blow more insulation in there. So everything you talked about, I'm experiencing. And I feel it at minus 28.
I'm sure you do. Somebody posted a question, how much will I save if I re-insulate my house? Well, you will definitely have a saving, but it's hard to know how much because it depends how well or poorly your house is insulated now and how much you're paying for heating costs. If you're below the minimum standard of the codes today, you will definitely save a lot in heating costs. Plus, your house will be more comfortable. Instead of needing 5 blankets, as Rudy says, you'll only need 1 blanket, and it'll be a thin one.
Exactly.
We're finding that we're having 66% savings alone here in the West Coast, but the application is a little bit different than what you're talking about.
Are you insulating the exterior of the building?
In interior,
The interior side.
in air tightness, creating air tightness,
Yeah.
and that's critical to anything that you do. And also separate the attic space from the living space and the living space from the crawl space. Each should be independently managed. That's what we're finding.
And a house is a very complicated system because everything depends on everything else. Windows, doors, insulation, all equates to comfort and savings of energy.
The energy file addresses that with the typical lighting system that you use. The windows, the type of windows, the application of windows, what type of its flange or inserted. The building code today, you see, like it's getting better, but it doesn't meet. It's a
Yeah.
minimum standard thing. Doesn't meet the regional climatic data that's now producing. So I would say they need to examine that, not only the material but the application of anything you do. It's critical. And
That will be addressed in the new energy, well, as the energy step code moves through.
yeah, that's what we're doing here now.
Yeah, and the house auditors come in and do, heat loss auditing.
The heat loss auditing,
Yeah,
lower door testing.
that'll
Yeah,
help.
blower door testing, and don't forget, almost every day there's new building products on the market. And what we're trying to do as inspectors is we're trying to help our client with the house that's, say, 40 years old, and we're trying to make it a little better and more energy efficient, but we'll never make it to today's standard because we have to deal with what we have.
That's correct.
Well, I've just run into a situation with this new construction where we have modular homes landed, and they're in our region here, we're not required to have rain screens, but these buildings were rain screened, and between the strapping, they have rock wool. So they have the tie-vac, the strapping, the rock wool, and then the siding goes over top of it, the hardy plank. And I was surprised to learn that the manufacturer specification does not require a secondary plane for the rock wool, even though the rock wool could become saturated and become filled with water. But their reasoning behind it under the new building sciences is that that rock wool will dry out behind the walls, right? Behind the walls. And I've voiced my concerns about it, because what happens if the hardy plank is installed tightly and it does buckle and shrink and move? It does. We know that.
Yeah,
And it opens up, and then we start to get moisture behind that rock wool. That rock wool can expand and cause oil canning on the siding, but they all seem to say that's it. Now, the point there, Harry, is that it's new materials, new components are being designed every day. You got to do a lot of reading and a lot of studying, and it all falls down to manufacturer specifications.
I agree with you 100%, and half the time it's installed wrong.
Yeah,
So
exactly.
people don't read the instructions, they just bang it on the wall.
Yeah, so really got to look at that as inspectors nowadays, and like these classes are very, very informative.
That's right.
I see a question here from Colleen, the housing manager. It says, if the home's been renovated about 5 or 6 years, or months ago rather, the roof was not replaced and the home was having problems with mold in the ceiling after renovation, and now the mold is coming back in the same areas. Any thoughts about that?
Eradication process never happened, and never you have an consistent heat source and moisture ingress that's happening continuously there. So the eradication process needs to happen before you put the building back together, then have consistent flow of heat and in the spaces that you're addressing.
Well, and
Yes.
if it's on the ceiling, it'll be a stack effect, right? Because
Yeah,
heat travels in all directions equally, but because we have the buoyancy and stack effect, it wants to raise to the ceiling. And again, this discussion about attics, it is so important to put your vapor barrier on there and then blanket it as well as you can. So if they've still got mold issues that are occurring, then
they have a problem with air leakage.
yeah, as Dennis says, that's not done right.
Yeah, that's what it sounds like. They need a good inspector to come and look at the workmanship.
Exactly.
Yeah, she kind of does a little bit of a follow-up. She says, the home I'm talking about had a lot of snow after the home was renovated. But I still think, and again, just my opinion, that certainly the snow would help contribute to more, we'll call it water or condensation or, access of moisture certainly into the attic space. But I think remediation is a whole other issue that if you don't do it properly, certainly you could have something return again.
Well, again, I mean, is the house a simple salt box, right? If it isn't, or if it's some sort of complicated Jenish roof system, I mean, it's very difficult for all of us to make some sort of concise decision about it without really looking at what we're looking at. I mean, we need more details.
I think so, but I think it's an air leakage problem if the mold is returned, and I don't think whoever did the renovation did it properly.
And what's the air-to-air handler in that house too? Has that been changed? Are we getting enough movement or fresh air return, balancing? There's a lot of questions.
A lot of things can factor into it, like you're indicating.
Yeah, there is. I mean, we're all deeply involved in the building sciences when we learn how all the components work together and have life expectancies within a system, right? So
Yeah. Richard,
What amazes me about some wannabe home inspectors, they think they helped their uncle build a deck, so now they're qualified to be a home inspector. As you mentioned, it's a lot more complicated than helping somebody build a deck. That's for sure.
That's okay, Harry. We had a guy over here that started up, used to be a guitar teacher.
He owns a truck.
So now he's a home inspector. He got himself an infrared camera.
maybe one last quick question here. Richard indicates or asks, should the temperature of the attic space be the same as the outside temperature?
No,
It normally never is.
just for the simple fact of the stack effect and the thermodynamics, energy rising in it, that space will always be a little bit warmer than the outside ambient air, but it's will be negligible, right?
On a day like today, it's probably just about as cold in the attic as it is outside.
Right. And that's where it is 20% intake and 1 in 300x. You need to keep that air moving in there.
Well, I could probably say, again, as any inspector would know, getting up into the attic on a hot summer day, certainly roof temperature can rise, but getting up in that attic space can be almost a deadly killer in some cases.
Well, that's why you want to do those inspections before 9 in the morning.
It could be like a sauna up there.
Yeah.
So anyways, thank you, Rudy, and certainly Harry, and everyone for listening in. Our next session is going to be on home inspection tools or inspection tools in general. Harry's going to be back with us next Thursday talking about inspection tools. So again, a lot more to learn about, we'll call it some of the tools, or some people might call them the toys that inspectors use. And have a lot of fun using, because, you know, there's some pretty neat tools out there today.
Sure is. Yeah.
So again, thank you.
Thank you, everybody.